There you go. So as you're copying it down, so let's read it. So a particle moves along the x-axis with a certain velocity. Okay, so already you should be thinking, okay, velocity is the derivative of position, right? You should be thinking about things like that. Okay, so we're given the velocity, there's that function. If the particle is at x equals 4 and t equals 2, find the position of the particle when t equals 3. So what should we recognize this as? We should recognize this as an IVP, right? I want to find the position, right? The question said, find the position. But what are you given to find the position? First of all, you're given the velocity, which is the derivative. So already you should be thinking, aha, I'm given the derivative of position and I want to find position. That sounds like an initial value problem. So hopefully they should have also given me what else? They should have also given me a point, right? And did they give us a point? They did. So this is an IVP for position. So what is the information we were given? Remember, IVPs come two things they give us. They give us the derivative and they gave us a point. So what were the two things they gave us? Derivative and point, right? So the derivative they gave us, they told us dx dt is equal to 9t squared minus 4t. So notice how there I'm using my knowledge that velocity is the derivative of position. So that's how you have to use that knowledge. That's it. Just knowing those basic terms. Now, what is the point that they gave me that is on the curve? Because remember, this is just going to get me back the original function with a plus c.
X equals 4.
X equals 4, but that's not a point. That's just x equals 4. I need a point. Remember, I need something like this. F of a equals b, right? I need two values, right? I need the independent and the dependent value. So it is true that x equals 4, but
F of 4 equals 2.
okay, so we have two things here. So you said x of 4 equals 2, and Sarah said x of 2 equals 4. Which is it? Uh-oh.
I think it's X of 2 then.
X of 2 equals 4. The first one? The first one? X of 2 equals 4?
No, I think it's the latter. X of 2 equals 4.
Okay, right. So it's the second one, right? Remember, it says when t equals 2. So the t value is 2, right? So if I'm doing x of t equals something, right? I evaluate this at t equals 2, and I get back out x equals 4, right? Remember how we do function notation. Okay, so we're given that x of 2 equals 4, and that is the second piece to this. And now we're in business. Now we're ready to solve the IVP. Questions so far about this? Because we have been going a little fast through this. Okay. So how do you think we would go about now solving this? What would be our next step?
We need to find the position function.
That's right. So what would you exactly do, Jan?
Take the antiderivative of 9t squared minus 4t.
Exactly. Take the antiderivative of equation 1, and that'll give you back the position with a plus c, right? So antidifferentiate 1. To get, so let's see. So the original function x of t is equal to the antiderivative of 9t squared minus 4t, right? If you want to get the position from velocity, you take an antiderivative. Okay, so this is power functions. So it should be pretty good with this. So 3t cubed minus 2t squared, right? Plus c. Again, you can think of this as 9t cubed over 3 minus 4t squared over 2. So that's antiderivative. Okay, good. Now what do we do? I have my position. I got it. So condition 1 is check. I have condition 1. How do I get condition 2? How do I make sure that condition 2 is true?
Do you have to set the equation to 4?
Okay, so I'm going to set this equal to 4, but there's something else I also have to do.
Plug 2 in for t.
Right, exactly. Also put in t equals 2. Right, exactly. So let's do that. So now use equation 2 to get c. Okay, so on the one hand, if I plug in t equals 2 into this, that's x of 2, right? Everyone knows that. But on the other hand, condition 2 tells me that this is supposed to be equal to 4. So plugging in 2 into my position function, working this out, let's see, that's what, 24 minus 8. So I get here 16 plus c. So if I plug in t equals 2 into my position, I get 16 plus c. But the problem told me that that position is actually supposed to be equal to 4. So then solving for c gives me that c equals negative 12. So that second condition is always going to lead to an equation involving c that you can solve for. And now we should be pretty much done. So what is our final position function? So our position function so x of t is 3t cubed minus 2t squared minus 12. Now, if you're unsure, did I make a mistake? Emily, did we make a mistake? We didn't, but what if you thought you did make a mistake, Emily? What if you weren't sure? Like it's an exam, you're like, wait, it couldn't have been that easy. Dr. G isn't that nice. So you go back to your original conditions. You can check them, right? Is the derivative of my function if I take the derivative of my position function, do I get back 9t squared minus 4t? You can check out, yes, I do get back 9t squared minus 4t. So that's checked. Is it true that x of 2 equals 4? If I plug in t equals 2 into this, do I get x equals 4? And the answer is yes, I do. So both conditions are checked, right? You can always double check them at the end. And now that they are double checked, I know that my answer is correct. Now, the one last thing is just make sure you actually do answer the question. The question did say, find the position of the particle at t equals 3. So all that's left for, like Kai said in chat, we're actually looking for x of 3, exactly. So hence, x of 3 is equal to, and whatever you get here, this is just arithmetic. So I think you get 51. So that's the final answer, 51.